In the 8th lecture, we will cover the hypothesis testing, include one-tailed and two-tailed tests. A hypothesis test is a method of statistical inference. It includes a series of steps that allow us to establish statistical significance. Statistical significance occurs when the result is not likely to be explained by random chance. Below are the procedures for hypothesis testing. First, the null hypothesis. Usually, it is a statement of no effect or no difference, and symbolized as H0. The null hypothesis is generally assumed to be true until evidence indicates otherwise. The alternative hypothesis or the research hypothesis is the statement that is being tested against the null hypothesis and symbolized as HA or H1. Second, the test statistic. The test statistic is a numeric measure of distance from the sample value to what is expected under the null hypothesis. The null distribution is the distribution of the test statistic, assuming the null hypothesis is true. Third, the decision making. The p-value is the proportion of the null distribution that is equal to or more extreme than the sample value. Significance level alpha is the cutoff point for the p-value. If p-value is smaller than the significance level, the results are statistically significant. And we may reject the null hypothesis since the sample is not likely selected by random chance. If p-value is larger than the significance level, then we fail to reject the null hypothesis since we cannot rule out the probability that the sample is selected by random chance. Here, we should not accept the null hypothesis because the test results are derived under the premise that we assume that the null hypothesis is true. We cannot prove the null hypothesis based on this assumption. Also, no significance cannot provide any evidence to accept the null hypothesis. Let's see some examples. A traffic officer would like to know if the traffic speed is greater than 40 miles per hour on a road with the speed limit of 40 miles per hour to determine if additional traffic signs are needed. Thus, we would set the null hypothesis as the average vehicle speed is less than or equal to 40 miles per hour, and the alternative hypothesis as the average vehicle speed is greater than 40 miles per hour. The test is called right-tailed, since we reject the null if the statistic is more right to the critical value. The right-tailed test suggests that we show more interest in the right tail. Here, we will take actions if the average speed is greater than 40 miles per hour, but we are fine even if the average speed is significantly less than 40 miles per hour. We should always include the equality in the null hypothesis. We should not use mu is less than 40 as the null. We may also use mu equals to 40 as the null hypothesis. The second case, a school decides to raise the minimum SAT score requirement if the average total SAT score sampled from all applications during the last 3 years is less than 1,000. Thus, we would set the null hypothesis as the average SAT score is greater than or equal to 1,000, and the alternative hypothesis H1 as the average SAT score is less than 1,000. The test is left-tailed because we reject the null if the statistic is more left to the critical value. It is a one-tailed test because we are concerned if the SAT score is less than 1,000 but not the opposite. The third case, the average male adult height in the US is 69 inches. A North Carolina officer would like to find out if the average male adult height in the North Carolina state is different from the US average. Thus, the null hypothesis would be the average height is equal to 69 inches, and the alternative hypothesis would be the average height is not equal to 69 inches. This test is a two-tailed test because we are interested in differences in both left and right directions. We reject the null if the statistic is more extreme to the critical value in both tails. From these examples, we learned that we need to set the appropriate hypothesis based on the research question. The research question may help us decide whether it is a left-tailed, right-tailed, or two-tailed test. This slide shows the testing procedures for both one-tailed and two-tailed tests using 3 examples in the last slide. The first example is the speed limit. We assume that the vehicle speed on the road is normally distributed. Thus, the sampling distribution is normal even when the sample size is less than 30. The officer randomly selected 16 cars driving on the road, and the average speed is 41 miles per hour. The sample standard deviation is 4 miles per hour. The null hypothesis is mu is less than or equal to 40 miles per hour, and H1 is mu is greater than 40 miles per hour. Because the population variance is unknown, the null distribution is a t-distribution with n-1, which is 15 degrees of freedom. The test statistic t is y bar minus mu divided by sy bar. Under the null hypothesis, mu is 40. Sy bar is s divided by square root of n, thus t is 1. The blue curve below is the null distribution. The p-value is the proportion of the null distribution that is equal to or greater than 1, which is the area in the right tail as shown in the graph. In Excel, the function t.dist calculates the probability with the first parameter is t, the second parameter is degrees of freedom, and the last parameter is the CDF flag. The function t.dist 115.1 calculates the cumulative probability of t equal to 1 under a t-distribution with 15 degrees of freedom, which is the proportion of the null distribution that is left to the t-value of 1. Clearly, the p-value is 1 minus the cumulative probability, which is 0.17. It means the area more right to the t-value is 17%. The significance level is 0.05, Thus, we need a p-value less than 0.05 to claim the result has statistical significance. Since the p-value is larger than 0.05, the result may be attributed to the random chance. Thus, we fail to reject the null hypothesis. At the 5% significance level, there is not enough evidence to conclude that the traffic speed is above 40 miles per hour on the road. No additional traffic sign on the road is needed. The second example is the total SAT score. The officer took a sample of 100 applications and found out the average SAT score is 964, and the sample standard deviation is 200. The null hypothesis, mu is greater than or equal to 1000. The alternative hypothesis, mu is less than 1000. Although the population variance is unknown, we may still use the DZ distribution here since the sample size is large enough. Thus, the z-score is y bar minus mu divided by sy bar, which is minus 1.8. For the left-tailed test, the p-value is the proportion of the null distribution that is less than or equal to minus 1.8, which is the area in the left tail as shown in the graph. Using Excel function norm.s.dist, the p-value is 0.036. If the t-distribution is used instead, the p-value is 0.0375. They do not differ much. We use a normal distribution here for the demonstration purposes. So the p-value is less than the significance level alpha of 0.05, and we reject the null hypothesis. At the 5% significance level, there is enough evidence to conclude that the average SAT score of the applications during the last 3 years is less than 1000. The third example is the male adult height in North Carolina state. The average male adult height in the US is 69 inches. Thus, the null hypothesis is mu is equal to 69, and H1 is mu is not equal to 69. The test is a two-tailed test because we are interested in the difference in both tails. Again, since the sample size is large enough, we simply use the z distribution as a null distribution. The test statistic z-score is 1.8. For a two-tailed test, the p-value is a proportion of the null distribution that is more extreme to the z-score of 1.8. Since it is a two-tailed test, the p-value is the area in both tails as shown in the graph. Thus, the p-value is 2 times of 3.6%, which is 0.072. If we use the t-distribution, the p-value would be 0.076. We fail to reject the null hypothesis since 7.2% is greater than 0.05%. 0.05. At the 5% significance level, there is not enough evidence to conclude that the average North Carolina state male adult height is different from 69 inches. The second and the third example have the same significance level and the z-score. But the conclusions are opposite because the second example is one-tailed, but the last example is two-tailed. The appropriate choice of the hypothesis should be based on the research interest. Thus, we should develop clear research questions before we start the hypothesis testing procedures. In summary, We learned the procedures of the hypothesis testing in this lecture. The null hypothesis usually is a statement of no effect or no difference, and symbolized as H0. The alternative hypothesis, or the research hypothesis, is a statement that is being tested against the null hypothesis and symbolized as HA or H1. The null distribution is a distribution of the test statistic, assuming the null hypothesis is true. The test statistic based on the null hypothesis leads to the p-value, which is the proportion of the null distribution that is equal to or more extreme than the test statistic. Significance level alpha is the cutoff point for the p-value, which is usually 5%. Statistical significance occurs when the result is not likely to be explained by random chance. If p-value is smaller than the significance level, the results are statistically significant, and we may reject the null hypothesis since the sample is not likely selected by random chance. If p-value is larger than the significance level, then we fail to reject the null hypothesis since we cannot rule out the possibility that the sample is selected by random chance. The hypothesis test may be one-tailed or two-tailed, depending on the hypothesis. If the alternative hypothesis is directional, then the test is one-tailed, and we compare the p-value with alpha. Otherwise, it is two-tailed, and we compare the p-value with alpha over 2. The appropriate choice of the hypothesis should be determined by the research question,